Friday regarding like comparing similar triangles. So this page is what you guys got already. We talked briefly about it, and then today we'll build on that. In the similar triangles, what can you say about their angles? How many in similar triangles? How many angles are in triangles? 3, right? So in similar triangles, all 3 angles, woohoo, are equal. All right. But what about the sides? Are all the sides equal? No, but they are proportional. All 3 lengths, I think Tayden is here now, are proportional. Proportional. Okay. What do we mean by proportional? Yep. The scale between them is equal. So for example, right here between the 4 and the 2 is 2. Between this between the 4 and the 8 is twice. Between the 4 and the 2 is twice. Between the 3 and the 6 is also twice. All right, so that's what we mean by proportion. When everything is the same, angles the same, length the same, instead of saying they're the same, what's the mathematical term? Congruent, excellent, right? Genius, yes. Okay, so that's the difference between similar and congruent. So let's do 3 quick examples. My lesson today will be short. It's like 10-minute lesson. Okay, so example 1. Using properties of similar triangles, find the width of the river to the nearest meter. So width of the river, meaning this right here. Okay, I want to find the length of that side. So first off, how many triangles do you see here? 2, right? I see that this triangle and I see this triangle. So that's why. So I have these 2 triangles that I can compare. Remember, we talked about proportional. Can I compare this length with this length right here? Yeah. No, it has to be like the same side with the same sides. Okay. So in this case, which side would I compare this length with? William? The 15. Right. I'm comparing this side with this side. What about the... Where is my pen? This one. Okay. What about the 17? Yep. The 50. Right. Right. Okay. Do I need to know how long these 2 are? No, as long as I know they're similar triangles, they're proportional. 2 sides proportional is the same as 3 sides proportional. So I don't even need that. Okay, so set up our set this up. I want to figure out this. So x over 15 equal, what's my second fraction? Cindy? 50 over 17. Why is it not 17 over 50? Cindy? The 15, 17 are the same triangles, so they both go on the same side of the division. Right, okay, so I started with this triangle, I start with this triangle. So you just have to make sure, when we did proportions at the beginning of this semester, we said it has to be the right order. Okay, so if we're starting with the top triangle, then we have to start with the top triangle on both sides. And then this bottom triangle. Okay, so the order of how you write the fraction matters. Okay, now that I have a fraction equals fraction, who remembers how to solve it? Gavin? Yeah, cross multiply. So 17x equals 15 times 50, 750. And so x equals? Divide it. 44 what? 0.1 what? Meters. Yes. All right. Huh? It was 44.1 or 44. Oh, sorry. The question does say to the nearest meter. Oh. So 44. Okay. So a lot of people in real life, they do similar triangles to figure out the length. So that, for example, in this case, nobody needs to be holding a meter stick or a measuring tape and going across the river. Okay. So that's why we use similar triangles. Other than similar triangles, okay, the same reasoning can apply to rectangles, similar shapes. It doesn't have to only be triangles. So find the scale factor k. So how many times bigger is this one to this? Tatum? 4. How did you get that? Yeah, exactly. Oops, that's a 4. Okay, so yeah, it's 4 times bigger. So the letter that we use is K for the scale factor. So if you use the big triangle divided by the small triangle, you'll get that it's 4. Okay. Now, what is the relationship between the areas of the two similar figures? Okay. So, Tayden, since I hear your voice, okay, how do I find the area of this small rectangle? Yeah, length times width. So 2 times 3 is 6 what? Square. Good. Okay, now the big one. $96. All right. Now, we said that this was 4 times as big. Does that apply the same to the area? Is this 4 times as big as well? No. How many times bigger is it? Do 96 divided by 6. Yeah, if you do 96 divided by 6, I don't get 4. I get 16 times bigger. Okay. So it's the square. Exactly. Good. And do you know why? It's because this side is 4 times bigger. This side is also 4 times bigger. So that's why it's 16 times. And there's actually a formula. Area of the big figure equals k squared times area of the smaller figure. Okay, and remember this is comparing similar figures. K is the scale factor. Scale factor? Oh, that's what you just said. Like how many times bigger is this compared to that? Okay. I think it's water. Yeah, I'm almost done. 2 more minutes and I'm done the lesson. Yeah, short lesson today. Okay. So, remember this formula, and this does this apply to any 2 triangles? Yeah. Can it be like? Can I compare this with a circle and a square? Yeah. William? They have to be congruent things. Not congruent. Congruent means exactly the same. They may be the same shape. Same shape, similar, right? It has to be. They have to be similar. So remember at the beginning when the very first thing I said with the lesson, these are the condition for it to be similar. So that's why in this case we were able to compare these 2 triangles, and this one we were able to compare these 2 rectangles because all the angles are the same, right? And all the sides are proportional. Right? And as long as that is satisfied, we can use this formula for the area. Okay, one last example. Okay, one last example. So I have, what does this read?
That means ABC is similar to DEF.
Right, triangle ABC is similar to triangle DEF. Right? Can I say triangle ABC is similar to triangle FED?
Yeah. No, because the same angle has to be in the middle at all times. That's why.
Right, angle has to be matching. So when you write it like this, what you're saying is angle B is same as angle E, angle A is same as angle D. So in this case, order does matter. Okay? Yeah.
Oh.
Good. So that's what Tatum is saying. So this angle A, I'm comparing it with angle D. Right? Angle B, I'm comparing it with angle E. All right, and angle C, I'm comparing it with angle F. Similarly with the sides, length AB, length DE. Okay, so find the scale factor K. Okay, so similar to what we just did. Okay, what's K? I'm going to calculate K. Rashan. Hi, how many times bigger is that one to this one?
Three times bigger. Like 0.2, 0.5.
0.5. What? Well, not 0.5, but how do I calculate it? Divide it, right? So what divide what? No, but should I do 8 divided by 12 or 12 divided by 8?
No, sorry, big over small.
So 12 over 8. So 1.5. So that means this triangle is 1.5 times bigger than this one. All right. Does that mean the area I just divided by 1.5? What am I dividing? Use the formula. We just came up with the formula, remember? Area of the big is k squared times the area of the small. That was like 2 minutes ago, guys. Okay, so what's the area of the big triangle? William? Yeah, and then k is? Yeah, square times area of the small. All right, 1.5 square. 1.5 square is 2.25. Right, and then when you divide it, 72 divided by 2.25. What did you get? Ethan? Did Ethan get full marks? Centimeter square. Units. You guys keep forgetting units.
How many marks do we use?
Half a mark.
Half a mark?
Yep.
So let's say it's like out of marks we get 9.5?
Yeah.
So what if you get the wrong answer but include units? We get half?
No. Good question. No. Okay. So yeah, that's it with the similar triangle stuff. So with this new package, okay, you can see the questions are on the bottom. It's listed on bottom, page 347. These questions right here. Is there 300 pages in this little pile?
Yes.
At the back, at the back, at the back. Okay, you will see on page 15. Okay, starting on page 15, you'll see these are the textbook questions. Okay, so like page 33, 33, 30, 34, 33, 35, and so forth. Okay, so questions are at the back of this package. What's also at the back of this package? answers. Alright, so answers starting on page 24. So questions and answers all at the back of the package. That's why it looks thicker than usual. Alright, so that's it for. Yes. Right.